Yes, good evening, everyone. This is Week-10 Salvador set. We'll be starting now. So, I'll be showing you some questions, and you can take 2 to 3 minutes to solve the question, and after that, we'll discuss these questions.
Excuse me, ma'am.
How many questions do we have?
Uh, I think we have around 6 questions.
Excuse me, ma'am.
Yeah.
Ma'am, can you take a doubt first? I have only one doubt. Can you take that first?
This is this is a live stream session. So if it's okay, I'll be taking it at the end of the session.
All right, ma'am.
Yes. Yeah. So can I start with the solve with the session? Yeah. Yeah. So this is the first question. In a box of numbered balls, balls are numbered 1, 2, 3, and 4, such that the probability of drawing a ball is proportional to the number on the ball. So the question is, if a ball is drawn at random from the box, then what is the expectation of number on the ball drawn? Yeah. So you can take 2 minutes to solve this question, and then we'll discuss it.
Hello.
Yeah. Yeah. So can we discuss this question? Yeah. So to solve this question, we'll first find the PMF of the distribution. So since we know that x can take the values 1, 2, 3, and 4, and now the probability of x, we know that it's proportional to the number on the board. So for 1, it'll be k, 2k, 3k, and 4k. That's because we know that it's proportional. So it will be 1 into some constant, 2 into some constant, and so on. So now to find the probability, we'll make use of the property that the sum of all the probabilities should be equal to 1. So k plus 2k plus 3k plus 4k is equal to 1. So this is 7, 8, 9, 10. So 10k is equal to 1. K is equal to 1 by 10 or 0.1.
Can
So
you just show the question once, please?
yeah. Yeah, is this okay then? Yeah.
Yes, ma'am.
Okay, so now that we know k is equal to 1, we can find the expectation using the formula summation x into p of x equal to x. So this will be,
Given the probability of drawing ball is proportional to the number on the ball, does it mean it's a multiple of that number, ma'am?
yeah.
Okay. Like one.
Hello, ma'am. I have recently joined this meeting. What is going on?
Yeah, it's a solve with us session. So we have a few questions prepared by the instructors, and we'll be discussing those questions.
Okay, ma'am.
Ma'am,
Yeah.
ma'am, can you show me the previous slide?
Yeah, I'll be showing it after just solving the question. I'll show you the slide. This is everything on this side is on the first slide. Yeah, so you will use the formula for the expectation to solve it. So we'll have 1 into 0.1 plus 2 into x. We'll just give the values here first. So k will be the 0.1, this will be 0.2, 0.3, and 0.4. So now x will be 0.2 and the probability will be 0.
The screen is not seen.
Yeah, ma'am. We are not able to see.
Uh, can you see it now?
Okay, okay. I mean, where you are writing. Okay, like a
Yeah,
black pen.
now?
Okay, yeah, it's okay.
Yeah. Okay, so
Ma'am, can you please explain from starting? Because the slides are not so there.
yeah, I'll show the slides also. Okay, so this will be how you solve it. Now I'll just show the slides and explain it then. Yeah, so to find the solution, first we'll find the PMF of the distribution. So we know that x can take the values 1 to 4, and the probability is proportional to the random variables. So it'll be 1 into a constant, 2 into a constant, and it should be the same constant. So we will write it as k, 2k, 3k, and 4k. Now, since we know that the sum of the probabilities is 1, we can just add up these and we can find k.
Okay.
Yeah, so, and here we'll just substitute the values to find the probability. And this is the formula for expectation. And you can just substitute the values and you'll get the final answer as 3. Yeah, is it clear?
Yes,
Yes,
ma'am.
ma'am.
It's clear.
Okay, so this is question 1. So previously it was a failure one. So now in question 1, you have the same description. And the question is, if a group of 3 balls is drawn at random from the box, then what is the expectation of the sum of the numbers of the balls drawn? You can take 2 minutes to solve this and then we'll discuss it. And this won't have any side deck, it's just, we'll just be discussing it. Yeah, can we discuss this question now?
Yes, ma'am.
So previously we found out what the expectation for drawing one ball is. So here we'll be drawing three, and we have to find the sum. So if we take x1, no, we'll take xi as the number on the ith bar. So if we have to find the sum, it'll just be x1 plus x2 plus x3, right? So we have to find expectation of x1 plus x2 plus x3. And now we also know that these are independent because these are in the question, it's said yeah, so because these are independent, what we can do is we can use the property that yeah, and we already found the property at the expectation of x1, so that is 3. So it'll just be 3 into 3 plus 3 plus 3. Yeah, is this the answer everyone got? We can just go through this for more clarity also.
Ma'am, I could not understand this question. Why should we have to add only three, the variable three?
Sorry, adding 3. Are you talking
Means,
about are you talking about over here?
yes, ma'am. We
Yeah,
taken three
because
now, 3 plus 3.
yeah. So if you
The
look at
question was
this,
that it was group now.
yeah. So here, if you look at it, xi was the number on the ith bar, and so in the previous question, what we basically found was the x was the number on the ball, right? So
Right.
we know that x1, x2, and x3 will basically be the same as the random variable x. So the expectation of x1, x2, and x3, each of them will be equal to 3. Yeah, so this is question 2. So you are given a PMF. Now you have to find the function, find the expected value of the function, which is defined as x squared plus 3. Yeah, so you can take 2 minutes to solve this question. Yeah, so I'm getting a lot of responses. So shall we discuss this question now? Yeah, so yeah, so this is our distribution for x. So now we have g of x as x squared plus 2. So if x is equal to 1, sorry, minus 1, then we have g of x as minus 1 squared plus 3, which is 1 plus 3, 4. If x is 0, then we have g of x, g
3.
of 0. Yeah.
Ma'am, where we submit the answer for this question?
You can just put it in the chat box. We're not using the paired x lab.
Okay, ma'am.
Yeah. So g of x will be taking the values of 4, 3, and 7.
7.
So we can find out the individual cases. So yeah, so if we can make the PMF for g of x now. So we have 3, 4, and 7. Now, if g of x is 3, then x will be taking the value of 0. So we can just write this value. So for
0.
x, for x has the probability 0.15, then the probability of g of x being 3 will also be 0.1. Now, we'll look at 4 later. For 7, we need x to take the value 2. So if x is taking 2 with the value of with the probability of 0.45, then here also will be 0.45. Now for 4, we can get 4 with either -1 or 1.
We should
So
add
yeah, we can add the probabilities of 0.1 and 0. So
0.4.
this will be 0.4. Now for finding the expected value of g of x, we can just use the formula. So this will be
3 into
3 into 0.15 plus 4 into 0.4 plus 7 into 0.45. Yeah, so the
5.2.
final answer, the final answer is 5.2.
Excuse me, ma'am.
Yeah.
Ma'am, in the week 12 content, they have given some additional content where they are asked, or where they have given a normal distribution and all those things. Is it there in the portion?
So this comes under extra content.
Yes, ma'am, extra content. Is normal distribution there for exam?
If they've given it under extra content, then most likely you won't be having it. I'll just go through the portion after we discuss the slides, and I'll
Yes,
confirm that.
Fine.
Yeah, but if they've told you that it's extra, then it won't. Yeah. So, so did everyone understand the explanation for this question?
Yes, ma'am.
Frank,
Yeah.
for when the value of g of x is 4, how do we have to do? Can you just explain it?
Yeah. So when
Because there
g
are
of
two values.
Yeah, so g of x can be 4 when x is either -1 or 1. So when it's -1, the probability is 0.1, and when it's 1, the probability is 0.3. So we can either get this or this. So we'll have to add the probabilities. So it'll be 0.1 plus 0.3.
So and then we have to do it normally.
Yeah, and then you have to do normal. Yeah, so the next question, we have prelude 1 to question 3. In a box, there are 10 chocolates, of which 6 are milk chocolates and 4 are dark chocolates. So 2 chocolates are drawn at random without replacement from the box. Find the probability that 1 dark chocolate is drawn among those 2 randomly drawn chocolates. Yeah, you can take 2 minutes to solve this. Yeah, we don't have the peer deck slides right now. It's just a discussion. So you can put your answers in the chat after 2 minutes. Yeah, so can we discuss these questions now?
Yes, ma'am.
Yeah, so yeah, if anyone needs more time for this question, I can uh, wait. Yeah, give me 1 minute. Yeah, so the Yeah, so the trick to solving this question is we can, from the question, we can understand what kind of distribution it is. So this will be a hypergeometric distribution. Yeah. So for this particular question, we don't need to figure that out. But for now, to find the probability that 1 dark chocolate is drawn, so in this case, we need 1 chocolate to be dark and 1 to be a milk chocolate. So the favorable outcomes, we have to select 1 milk chocolate, which will be done in 6C1 ways, and 1 dark chocolate, which will be 4C1 ways. And the total ways of selecting the 2 chocolates will be 10C2. So you have to divide the favorable outcomes with the total number of outcomes. So you'll get 0.5. Yeah, yeah. Some of you did get the wrong answer. So is it clear why it's 0.53 now?
Can you just show the question again?
Can you show the question, ma'am?
Yeah. Yeah, this is the question.
Yes, ma'am. Got it.
Yeah. So now you have prelude 2 as well. Now we have question 3, right? So what is the expected number of the dark chocolate strawn?
I'm actually sorry to interrupt. I'm unable to join the CT session. I just want to know whether it's for everybody
I
or
don't know
not.
what is the difference.
Yeah, I'm not sure about the CT session actually. If it's there in the calendar, it should be happening right now.
Ma'am, until 5 minutes ago, there was no sir in the meeting.
Yeah, is this a TA
Because I'm
session?
not let in, ma'am, so I don't know what to do.
Is this a TA session or an instructor session?
TA session,
TA
ma'am, but
session.
Okay, I'll just confirm in 5 minutes and tell you. Yeah, I'll give you 30 seconds more for solving this question.
yes, ma'am.
Yeah, so this question, it follows a hypergeometric distribution. So if n is the number of chocolates to be selected, we have to select 2. So n will be 2. The number of dark chocolates in the box, we have 4 dark chocolates. So n will be 4. And the total number of chocolates in the box, they said there are 10 chocolates. So capital N will be 10. So we know that the expected value of the hypergeometric distribution is m into n divided by capital N. So we can just substitute the 3 values and we'll get the answer as 0.8.
How do we know whether it follows hypergeometric distribution?
Yeah, that's because we have to select. That's because we have to select 2, and we know that we can. We'll treat it like getting a dark chocolate as a success and getting a milk chocolate as a failure. So since these 2 are limited, if you look at the hypergeometric distribution description, you'll know that these are the characteristics that you need. So there will be 2 sections. There'll be 2 situations. One will be getting a success, the other will be getting a failure, and you'll have a limited number for those 2. And you'll have to say you'll have 2 or 3 a certain finite number of selections.
Ma'am, how is hypergeometric different from binomial?
Ma'am?
Yeah.
What is mean by hypergeometric distribution?
Haven't you learned this in the lectures?
No, ma'am, I didn't hear it.
It might be in one of the tutorial.
Is it in tutorial?
Yeah, it might be. I'm not very sure. Can anyone else respond?
Up to week 10th, it's not there. It's in week 10.
11.
Yes, ma'am. I
Okay.
saw week 10 pictures only.
It's not there in the week 10
Yes,
content.
ma'am.
It's in the week 11.
Okay. Okay. So even without this, you can find the solution. You'll just have to consider all the cases. You'll have to make a PMF like this one, and
So
then you
can
can.
we, ma'am, can we also do like 2C1 by into something like that using the regular?
Yeah, that's what I was saying. You can find the individual values for all the possible options. You can make a PMF and then do it. Yeah. So responding to so previously I got a question regarding the difference between binomial and hypergeometric. So in a binomial, if you're the selection will be with replacement, but in hypergeometric it will be without replacement. That's the only difference.
Okay, thank you, ma'am.
Yeah. Yeah. So this is the fourth question. The past records of a football club in golden goal matches are analyzed. Assume that the result of a match is independent of the other match. So HI is equal to 0 if P is HI is equal to 0 with probability 0.4 and 1 with probability 0.6. So H is 0 if the team loses and it's 1 if the team wins. What is the expected number of wins in 5 matches? Yeah, you can take 2 minutes to solve this. Okay. Yeah, so we will discuss this question now. So if so this is the information for one match. We have to find the expected number of wins in 5 matches. So what we can do is we can take individual matches as XI, and there are 5 matches, so there can be X1 x2, and so on until x5. So we'll use the property that expected value of x1 plus x2 plus x3 plus x4 plus x5 is equal to the summation of the expected values. And we also know that these are the same distribution. So we can just write it as 5 into expected value of x. Now, for expected value of x, we know that it will either take the value 0 or 1. So the probability of getting 0 is 0.4. And for 1, it is
Can you please
0.6.
show the question just
Yeah, this is the question.
yes.
Yeah, so for one distribution, it will be 0 plus 0.6 or 0.6. So the sum of the expectation will be equal to 5 into 0.6.
Ma'am, can you show once the question?
Yeah.
Ma'am, do we have to sum up the values of each of the xi's to find out the expected when 5 matches? Ma'am? Like, why are we summing up all the xi values?
Because there are two ways of doing this. Either you can actually find the distributions, the PMF for the 5 matches, or you can just say that the 5 matches follow, each of the 5 matches follows the same distribution.
Independent.
Yeah, these are independent and identical also. So we can just say that the number of wins it'll be so if the team won 3 matches, let's say, if they won the first match, the third match, and the fourth match, then x1 will be 1, x2 will be 0, x3 will be 1, x4 1, and x5 0. So to find the total number of matches that they won, you can just add this up, add up the random variables and get 3, right? So to find the number of wins, all we have to find is expected value of the summation of all the x's. And then you can use this property because each of them are independent. You can just say that it's 5 into expected value. Yeah, so the final answer is 3. Yeah, so everyone did get 3. So yeah, does anyone have a doubt in this question?
No.
If you don't mind, can you like explain again?
Yeah, so one distribution, we know that it will for one match, we can say that the distribution is xi equal to 0 and 1 with these probabilities, right? So yeah, so we have to find the expected number of wins. So here we're saying it's 0 if the team loses and 1 if the team wins. So as I said, if we're considering this situation where these 3 are the wins, that means 2 and 5 are the losses. So in that case, x1 will be 1 because in the first match they won. x2 will be 0 because the second match was a loss. So similarly, you can write x3 as 1, x4 as 1, and x5 will be 0. Right? So if you wanted to see the number of wins, you can just add this up. 3 of those were wins. So you'll get the sum as 3. So that is the number of wins, right? So what I'm saying is in the question, what we have to find is the expected value of the summation of x.
Got it.
Yeah. So now we also know that x1, x2, and all of these follow the same distribution x. And we know that they're independent because they told us that the result of a match is independent of the other matches. And they're identical also. So we can just say that if this is equal to the sum of the expectations of the individual distribution. And since they're identical, you can just say 5 into expected value of x. And you can find the expected value of x using the formula and just substitute it. You'll get 3.
Ma'am?
Yeah.
Ma'am, can we do this problem in the form of table before question answer? Xi and probability of Xi.
Like this?
0 matches, 1 match. Yes, ma'am. Can you explain in this?
We can, but this would be very hard to solve. It would take a long time to solve it. So this is how they're expecting you to solve it.
Okay. Ma'am, what is the probability of winning 2 matches?
So we'll have to select 2 matches from the 5. First, we'll have to select the 2 matches, and then we'll have to find the and then we'll just have to find the total. So the 2 matches which it'll win would be 5C2, and the probability would be the total. The total would be 2 to the power 5, because each match could either be won or lost. So and then you'll have to find 5C2 into you'll have to multiply. So there are 2 wins. So the probability of winning is 0.6. So into 0.6. Yeah, you don't have to look at 2 to the power 5. Sorry, So you'll have to select the 2, and then you'll have to multiply the probabilities. So they'll have to win 2, and they'll be losing 3. So this will be the problem.
From 5 matches, it is.
Yeah, that's right. So that's why we're selecting 2, and we have to. It's 2 wins and 3 losses.
Okay.
Yeah.
Ma'am, can I ask activity questions?
After we're done with this, if there's still time, we can take the activity questions.
Okay.
Yeah. So now we'll be moving on to variance and standard deviation questions. So so expectation is only a value of the central tendency. It does not give you any details about the variation. So that's why we use variance. And standard deviation is just the square root of variance. Yeah. So these are the formulas for variance and for standard deviation. Yeah. No one has any doubts on this, right? This will start in the lectures. Yeah. So now we look at question 5. It's the same.
Can you show that slide again? The variance of random.
Yeah. Yeah. Can I show the 5th question now?
Ma'am.
Just a minute, please.
Yeah.
Yes, ma'am.
Yeah. So this is the question. Yeah. So for those who are not able to join the CT meeting, it is going on right now, but it's an instructor session, and you'll have to admit everyone into the meeting. So those who don't have the IITM official link.
Ma'am, what you said, can you adjust your accent? Like, I'm not getting properly.
Yeah, I was saying there is a CT session going on right now. It's a session by the instructor, not by the TA. So those who don't have an official IITM email ID, they won't be able to join the CT session. You'll have to wait until the instructor admits you.
No, ma'am, there is no one there, ma'am. Everybody has left and no one is there. It's not going on.
Okay, I got this information from a TA, so I'm not sure how what's going on right now.
Yeah, nobody's there,
Excuse me, ma'am.
ma'am, there. Everyone was.
Okay.
Excuse me, ma'am.
Yeah.
Ma'am, do foundation level students get the IITM?
Yeah, so if you
email
pass
ID?
the qualifier in this term, then I think it'll take some time. You'll surely get it either in the beginning of the next term or in this term itself.
Okay, either by the end of this term or in the beginning of the next term, right?
Yeah.
Okay. Got it.
Yeah, so I'll just give 2 more minutes for solving this question and then we can discuss it. Yeah, so shall we discuss this question?
Yes, ma'am.
Okay, so it's the same as the previous one, but we have to find the variance. So we'll use the formula, expected value, the variance is equal to so yeah, so we know that.
Yes.
Yeah, so here we know that we can find individually for xi squared and xi, and we know that for 0 we have probability 0.6, 0.4, and 1 will have 0 probability 0.6. So 0 square and 1 square will just be 0 and 1 itself. So we'll have 0.6. And now if we look at expected value of xi, we'll get 0. We already found the answers to be 0.6. So now the variance formula will be expected value of xi square 0.6 minus expected value of xi the whole square. So we have 0.6 into 1 minus 0.6. So 0.24 will be the answer. So if another way of doing this would be, you can see
No,
that
ma'am,
this is
0.24 into 5. Then the answer 1.2.
yeah. So
Because
the variance of xi one distribution will be 0.24. Yeah, and now you can, what we have to find is this. Yeah, so now we know that all of these are independent because in the question they said that the result of one match is independent of the other matches. So we don't have to look at the covariance terms. We can write this as variance of x1 plus variance of x2 plus so on until variance of x5. Yeah. And all of these, as we discussed before, follow the same distribution. So we can write this as 5 into variance of x. 5 into 0.24. So yeah, so the answer is 1.2. Yeah. Yeah, so another way of finding the variance of xi is so we do know that this is a binomial distribution and we no, a Bernoulli distribution if we're only looking at one match. So the variance of a Bernoulli distribution is p into 1 minus p. So p is 0.6, so we can just directly say that it's 0.6 into 0.4. Yeah, is this question clear?
Hello, ma'am.
Yes, ma'am.
Yeah.
Hello, ma'am.
Yeah, what is it?
There was a doubt session from 7 to 9.
For stats one?
Yes, ma'am.
Yeah, so that session was cancelled for today, and instead we have the solve with the session now.
Okay, ma'am.
Yeah. So this is the last question for the session. So if y is equal to as plus b, which of the following are true? Yeah. And this is a direct question, so we can discuss it right now.
1 and 3.
So yeah. So yeah, first and third. This is just the property of expectation itself. It's given like this. Does anyone need an explanation for this one?
Yes, ma'am.
So
Yeah,
only
ma'am.
10 people are giving that.
1 and 3 are the answer.
Yeah, 1 and 3 are the right answers. Yeah, so since we have more time left for the session, we can take some doubts. So
Ma'am, can you just show the 8th question, please?
the sixth question.
Yes, you can speak. Yes, ma'am, thank you.
Yeah,
Is
the
this
answer
a
is 1 and 3.
session for week 10 solve with the session?
Yeah, this is a week-10 solve.
Question is over now, ma'am?
Yeah, that's all. I think a few of you had some doubts, so we can take those doubts.
Okay.
Ma'am, I have routed it to the course.
Sorry,
10
can
points.
you can raise your hand and I'll take it.
Ma'am, can I ask?
Just 1 second.
Yes, ma'am.
Yeah, so I'll take it in the order of the people who raised their hand. So Arnav had his hand raised first. So yeah, Arnav, you can ask your question.
Yes, ma'am. Ma'am, I have a doubt in activity question 10.2, question number 9.
Yeah.
Ma'am, which session is live on the IIT Madras YouTube channel? That statistics session 1. Which is session?
It's this session itself.
Which session is this, ma'am? That statistics session 1 is streaming now on the YouTube.
Yeah, it's this one. It's the solve with us 10 week 10 graded session.
No, ma'am, it is another session in which the teachers are viewed in self-
Okay, I'll just check. 1 second. Yeah, it is this session. It's just I think it's called week 10 session 2 in the on the 10. Yeah, so activity 10.2 question number
Question number 9, ma'am.
9. Yeah. Yeah, so this is a uniform distribution that's given to us. So we can just use the formula for the expectation. Otherwise, what you can do is you can just solve it using the formula itself.
Ma'am, if we are using the formula, then according to the formula, we'll be getting n+1/2, right?
1 second. We'll get 1 into 1 by n plus 2 into 1 by n plus so on until n into 1 by n. So here, so here I
We'll
can
take
take
a
1 by n.
common, and 1 plus 2 plus till n, it will then by the formula n into n+1/2,
Yeah.
and 1 by n, then n will be cancelled
Value
by
of
n
n
into
is
n+1/2
19.
will be remaining, right?
19 is the answer.
1 second. So n will get cancelled out here, and we'll get n plus 1 equal to 20. Yeah, n will be equal to 19. That's good.
Okay, okay, ma'am. Got it. Thank you, ma'am.
Yeah. Any other doubt?
No, ma'am.
Yeah. Okay. So, Sushmita, you can ask the question.
Good evening, ma'am.
Yeah, good evening.
Ma'am, can I ask a doubt from week 11? Week 11, activity 11.
Can you ask that in the upcoming session? I'm not
I stuck in just one question. If you please solve this, it will be very helpful.
Yeah, I'll look at the question. I haven't revised the week 11 concepts yet, so I'm not sure if I'll be able to answer that. Yeah, which question?
Okay, no issues.
Yeah, it's okay. I can try. Which question is it?
Ma'am, activity 11.3, last question, I guess question number 4.
Okay.
5, sorry, it's question number 5.
Yeah, suppose that 4.5% of the people living in a particular city own a Creta. A survey has been conducted to know what brand of cars people use in the city. What is the probability that the 12th person being interviewed during the survey is the second one to own a Creta? So until here, you just learned binomial and Bernoulli, right? Okay, so this will follow another distribution, but I don't think you've reached there yet. So what you can do is, if the 12th person being interviewed is the second one to own a Creta, then we can say that from the first 11, 10 don't own one, and 1 owns a character, right?
Yes, ma'am.
That's why the 12th person owns one. And this will be the second person. So you can find the probability using this will be a Bernoulli distribution, where owning is a success and not owning is a failure. And we know that the probability of a success is
0.045.
yeah 4.5%. So 0.045 because it's 4.5 by 100. And so the probability of a failure will just be 1 minus
0.955.
Yeah. Yeah, so this will follow a binomial distribution, so you can just use that here. So you'll have to find n will be 11 here, and what you want, the number of successes will be 1. So you'll have to find, so r will be 1. Yeah, you'll have to just use this. Substitute n, r, p, and yeah, 1 minus.
Ma'am, I have already done this, ma'am, but the answer is not tallying with
Okay, so you did 11C1 into
0.045 and 0.955 10.
No, this is week 11.
Where did the 0.045 is come from?
Because it says 4.5%.
Okay, ma'am.
11C1 is just 11. Yeah, this is not giving the right answer.
Yes, ma'am, I have done this, but I got 0.3123.
Yeah. Yeah, I'm not sure where we went wrong exactly.
Okay, ma'am, I will come back at week 11 session.
Yeah, sure.
Okay, thank you.
Thank
you. Okay.
Ma'am, you said there is a special kind of distribution used to solve such questions. Ma'am, by any chance, was it the exponential distribution?
No, it won't be the exponential. I think it's called geometric distribution. Yeah, I think it's a geometric distribution. Yeah, as I said, I should revise all the week 11 concepts, week 11 and 12 concepts. So yeah, I'm not very sure. Exponential will be used when you have waiting time and things like that. Yeah, so okay, Gurmukh, you can ask a question.
Ma'am, I had a question related to the course. Ma'am, when will we be taught like random vectors?
I don't think you'll be learning about random vectors.
Ma'am, anytime, not even in stats too.
I don't think so. What do you mean by random vectors exactly?
Ma'am, random vectors are basically collections of random variables taken together.
Oh, okay. Yeah, that you will be learning that in stats too.
Okay, thank you,
Yeah,
ma'am.
we call it. I think we'll be using a different term, multiple random variables.
Yes, ma'am.
Yeah. Okay. Yeah. Is that all or anything else?
Yes, ma'am. That's all.
Ma'am,
Yeah.
I have a doubt.
Yeah.
On week 10.3, I
Yeah,
just want to
Anurag, you have to raise your hand. I'll get to your. Oh,
know
did you
where
have your
the,
hand raised?
no, I don't know where is the option.
Uh,
On reactions.
Ma'am, can I ask my doubt?
Oh,
I
okay.
was and
yeah,
stop,
yeah,
ma'am.
yes, sir. Yeah. No, Aryan, you can ask a question.
Activity 10.6, question number 3.
Yeah, 10.6, right?
Yes, ma'am.
Yeah, question number
3.
Yeah. So I think in this one, in the question, so what is the formula for variance of x plus y plus z?
If they are independent, we can add them individually.
Yeah, but in this case, are the three independent?
I guess y x equal to y, something like that is given. You can check
Sorry?
the question.
Yeah, it says x and z are independent. And we also know that y is equal to 2x. So if
Y
y
and
is
x
equal,
are not independent.
yeah, x and y are dependent. So we can't use the formula here. But instead, what we can do is we can just take y as 2x here itself. So we can write it as 3x plus z. Now we know that x and z are independent. So we can just write this as if x and z are independent, then 3x and z will also be independent. So you can write this as this. So if you're
9
taking,
times z.
yeah, 9 times variance of x plus variance of z. And for x, it's 2 and 7 for z. So 9 into 2 plus 7. And now you have to find the standard deviation. So that will just be the square root of this, which is 5.
And 10.3, question number 4.
Yeah, so this will also be using the, so we solved a lot of questions using this concept, right? Summation xi is equal to summation of x, expected value of xi. So yeah, so here basically what we have to find is the sum of all the individual profits or losses. So if we take xi as just for one yeah. Yeah, so if we're just considering one one mobile. So we know that for non-defective ones, we get 2,500. For defective ones, we get minus 10,000. And the probability of getting a non-defective one. So if we have 20 in total, then we know that from 1,000, 100 are defective. So if from 1,000, if 100 are defective, then 900 will be not defective. So if we're getting 20, then getting a non-defective one. No, we'll just consider one here. We're only buying one mobile. We'll look at the 20 later. So if we're getting one, then the probability of getting non-defective will be 900 by 1,000. For defective, will be 100 by 1,000. So we can write this as 0.9 and this will be 0.1. So this is just for one mobile. So if we're taking x1, so if we're finding the expected value of x1, which is just for one mobile, we'll get it as 2,500 into 0.9 plus minus 10,000 into 0.1. Yeah, so this will be 2,250 minus 1,000. So this will be 1,250. So now we have 20 such mobiles and each of them will follow the same distribution. So to find expected value of summation xi for I from 1 to 20, we can just find summation I from 1 to 20 of expected value of xi. So when we're summing the same thing 20 times, it'll just be 20 into 1,053. So that will be 25,000. I'll just check if it's the right answer. Yeah.
Can you please show the solution?
Yeah, this is the solution. Is it clear?
Yes, ma'am.
Why do we take the 20 into the expectation?
Yeah, because this is only for one mobile. And we have 20 such mobiles which will follow the same distance.
Ma'am, practice.
So we have to, yeah.
When I wanted to, like, I had the same doubt, but I didn't heard when you were explaining.
Okay, I'll just explain it again.
Okay.
Yeah, so if we're looking at one mobile, this is only for one mobile. From here to here, we're only looking at one mobile. So if it's non-defective, we'll get a profit of 2,500. And if it's defective, it'll be a loss of 10,000. And this is the probability. So if it's only one mobile, we know that from the 1,000, 100 are defective and 900 are not defective. So we'll just find the probability as 900 by 1,000 for non-defective and 100 by 1,000 for defective. And we can find the expected value of the of x1, right? x1 is the profit of one mobile. So this will be 2,500 into 0.9 plus minus 10,000 into 0.1. And we'll get that as 1,250. Now, this is only for one mobile. We'll have to find the profit for all the 20 mobiles. And the profit for all 20 is just the sum of all the sum of the profit for the individual mobile. So we can multiply expected value of xi by 20. So we'll get the answer as 25. This is just
Ma'am,
based on
this one, if you can explain EX1.
yeah. This is just using the formula. Expected value of x is equal to summation x into p of x.
Yeah, no, what is the X1 even?
Yeah, x1 is profit of one mobile. So this is the profit and this is the probability. So we're multiplying profit and probability and adding.
But why we are adding, ma'am, 25,000 0.9 plus minus 10,000 0.1?
We're just finding the expectation using this formula.
Oh.
This must have been taught to you in the lecture. I just directly use the formula for this part. Yeah.
Okay.
Hello, ma'am.
Yeah.
Ma'am, actually, I have a journal doubt, ma'am.
Just a
Take
second,
it forward.
Pagal. Aryan, were you done asking
No,
questions?
ma'am. I have some.
Yeah.
Question number 3 of this one.
Is it the same question? I think it changes when you.
An entrepreneur has invested. Yes, ma'am. This is.
Um, hmm. Yeah, so this is again using the same principle. We'll have to find each of the individual expected values. I'll just show you how to find one, and you can find it for the rest and add it. So just for finding one, we have we'll have yeah. So we'll just look at the first startup for now. So if it's a profit, we'll look at the profit and the probability. So if it's a profit, it could be 10 lakhs. And
Which
if
question
it's
of practice assignment is
third one, and if it's a loss, it will be -3. And now the probability of getting a profit is 0.2. So profit will be 0.2 and the loss will be 0.8. So now the expected value of x1, which is the profit for the first startup, will be 10 into 0.2 plus -3 into 0.2. So 2 minus 2.4. So for just this one, you'll have a loss of -0.4. So similarly, you'll have to find it for
All the
x2.
individual and then add.
Yeah, so this will be the sum of all the profits you get, right?
Yes,
Profit or the loss. So, and then you can use this formula. You can find the individual one and then just add it up.
Okay, ma'am. And then question number 21 in this.
Okay, so
ma'am, I did done this by expanding it like x
Yeah.
square plus 4x plus 4, and it was not working.
yeah, variance of y. I think that's because x and 4x, x square and x 4x are dependent. So you will have a covariance term.
Okay, ma'am. So means we have to find like this x plus 2 means first find out x plus 2 and then square it and then find probabilities.
No, I
X
don't
square
think you can
variance.
find. No. I don't think variance of this won't be equal to. This won't be equal to variance of x plus 2. You can. I think you can use this formula instead. X squared minus.
Okay.
So here it would be expected value of x plus 2 the whole square plus minus expected value of x plus 2. Sorry, this would be 4. And yeah.
Okay, ma'am. Thank you.
Yeah, we're converting it into expectation because then we don't have to worry about it being dependent. Yeah, and then you can expand it and find it. Yeah. Anything else?
No, ma'am.
Okay. Yeah. Yeah. Sagar, you can ask a question.
Yes, ma'am. Ma'am, actually, I have stuff related to a weightage of week 9 to 12.
Yeah. So in the end term, you'll have 9 to 12 will have more weightage than the other week.
So it's a percentage criterion, something like week 1 to 4, 40%, or is it something you can tell?
I am not very sure about it.
Okay, ma'am. Thank you.
But for the end term, you will have to study it.
Okay.
it's just that the last few weeks will have a little bit more.
Okay.
Yeah.
Thank you, ma'am.
Yes, Ab. Anything else?
No, ma'am.
Okay, yeah. Yeah, Anurag, you can ask a question now.
Ma'am, 10.3. I just wanted to know how to make the cases.
Yeah, which question?
It's question number 3. Like I started.
Yeah, so in this one again, you'll have to did you understand how to solve this question?
Actually, I had not. That's why if you can explain the number 3, then it may help.
Yeah, I think for this one, did you figure out how to solve this question?
Yeah.
Yeah, so it's the same concept in 3 and 4 as well. So in 4, what we did was we found the profit or the loss for one mobile and we added it up for each of the 20 mobiles will follow the same distribution. So we can just add the individual expectation. So here in this question, yeah, so we'll take x1 as the random variable that a woman is selected or a man is selected. So if a man is selected, we'll give it 0, and if a woman is selected, we can have 1. So if we're only selecting one person, we'll have if we're having 0 men, that means if we're having 0, it means it's one man. So we'll have to select 1 from the 8, and the total waste would be 20. So 8 by 20. Similarly, if the one person selected is a woman, then we have 12 by 20. If it's just one person. Are you with me until here?
Yes.
Yeah. So now this was only selecting one person. So now we can take x2 as the second person to be selected, x3 as the third, fourth, and the fifth. So all of these will follow the same distribution x. So what we can do is we can use this principle again. So this will be, yeah, so before that, we'll find the expected value of xi, which is 0 into 8 by 20 plus 1 into 12 by 20. So this will be summation. There are 5, so 5 into this will be 12 by 20. 5 into 12 by 20. That will be 12 by 4 or 3. So let's use G. Yeah. Yeah, is it clear?
Yeah, ma'am. And if in case the question comes like in case of women, it is men, then will it be same? Look,
no, in that case, we can take the success will be getting a man and a failure will be getting a woman. So success we'll have to do the expectation will be at 8 by 20 in that case. So in that case, when you're doing that's and yeah, at 5, you have to do summation 8 by 20, which will be 5 into 8 by 20. Yeah, and if you look at this, it'll add up as well. So expected value of getting the expected number of women is 3 here, and expected number of men is 3. So 3 plus 2 is 5, which is the number of people we're selecting.
Ma'am, we are like selecting one person. It could be either men or women.
Yeah.
And the same is like all the events are same. Then X2, X3, X4, X5.
Yeah. You'll just have to figure out what distribution to make over here for one person. So here it's just usually it'll be a Bernoulli distribution, and you'll have to sum it up any n number of times.
And
Ma'am,
the
I have
same,
doubt in 10.6 question number 3 activity.
ma'am, and
1 second.
yeah, the number question number 4, ma'am. After this,
Yeah, we discussed that.
yeah. So we make a case of one phone, and it is defective or it is proper, like good.
Yeah, but in this case, it won't be 0 and 1. It will be 2,500 and minus 10,000.
Oh.
Here we just had to check if it's there or not. So 1 means it's there, 0 means it's not. But here we have to find the expected profit, not the expected number of defective ones. So,
yeah. So profit means we'll take the proper phone, that is we'll take at 2,500, and the last one will take minus 10.
Yeah, and the probability will be for selecting a non-defective one, it'll be 900 by 1,000. For defective, it'll be 100 by 1,000.
Oh. Oh. Yeah. Okay, I got it. Thank you.
Yeah. Now, who is the next person speaking? Yeah.
Now I have a doubt in week 11. Didn't understand the concept of Poisson distribution.
Yeah, we'll be sticking to questions until week 10 today, actually. So could you ask that in the session tomorrow, maybe?
Okay.
Yeah.
Okay.
Yeah, sorry. Yeah, Ripu Sudan, you can ask a question. Did I pronounce your name correctly? Are you there? You can say something in the chat also if you want. Yeah. Okay, then Danya, you can ask the question.
Are you speaking to me?
No, I was talking to the next person who had raised
Ma'am,
that.
I'll just ask it in a few minutes because it's another session also.
Okay, Danya, just raise your hand again. Huh? Yeah, Priyadarshini, you can ask the question. I can see that you're unmuted, but I can't hear you. Yeah, I can barely hear you. Could you repeat? Okay, this one. Yeah. Yeah, so this is yeah, so here we have the probability mass function. So if we're just putting it in a tabular form, x can take the value 0 and 1, and otherwise it's 0, so we don't have to write that. So if probability of x is equal to x, then for 0 we have 3k square minus 3k, and for 1 we have 2k square minus 1. So the way that we would solve this question, yeah, we do have to, you did use the correct method. So we'll have 0 into 3k square minus 3k. Oh, sorry, this is the expected value. Yeah, 3k square minus 3k plus 2k square minus 1 is equal to 1. So 5k square minus 3k minus 2 is equal to 0. So yeah, so we'll have to use the quadratic way of solving it. So k will be equal to
K is equal to 1.
yeah, b square minus 4 ac. Oh, okay. Yeah, this will give you the right answer.
You have done an example.
Yeah, so 3 minus 7 will be negative. I don't think. Well, okay, 3 plus 7 by 10 is 1, and 3 minus 7 by 10 will be minus 0.4. I think this will give you a negative value, so 1 will be the answer. Yeah. Anything else, Priyadarshini? Okay. Yeah. So, Rikusudan, you can ask your question.
Ma'am, activity 10.6, question number 3.
Yeah. How did you solve this question? So
I
what is
get confused.
yeah. So what is the formula for variance of x plus y plus z?
Variance of x plus variance of y plus variance of z.
Yeah.
These are
only-
independent.
Yeah, if they're independent. So are they independent?
Yes, ma'am.
Can I know how you know they're independent? This is 10.6, so question 3. Yeah, so we know that y and z are independent. That is given to us. What about the rest? We also know that y is equal to 2x, right? Yeah, if y is equal to 2x, then are y and x independent?
Ma'am, can you please copy the question on this page?
Yeah, okay. Yeah, this is the question. Yeah, so we know that x and z are independent, and we also know that y is equal to 2x. So how can you say, you said that all 3 are independent. So can I know how you found that?
So first option itself cannot be used to confirm that is not correct.
Okay, so because y is equal to 2x, we x and y are dependent on each other.
Yes, ma'am.
So we can't use this formula. Instead, what we can do is, since we know y is equal to 2x, we can just directly substitute it here. So we'll just have to find variance of 3x plus z. Now we know that x and z are independent, right? So
Yes,
3x
ma'am.
and z are also independent. So we can just write this as 3x plus z. Now we can take 3 outside.
9 of variance of x plus variance of z.
Yeah, and variance of x is 2 and variance of z is 7. So we'll get 18 plus 7, 25. So the standard
Root
deviation,
of 25.
yeah, which is
Okay,
5.
ma'am. Thank you.
Yeah. Anything else?
No, ma'am.
Yeah. Danya, are you there now? Okay, Arnav, you can ask your question.
Yes, ma'am. Ma'am, the first question in the 10.6 only. Uh, how come first option is not the answer?
Okay, so what is the variance formula? It's
You said, oh, okay.
So we will have to find
X square plus mu square minus 2x mu. Okay, ma'am. Got it, ma'am. Got it.
yeah, just expand this sign the square root. I don't think you'll get it either.
Yes,
Yeah,
ma'am.
this term
Got
will
it.
also be that. Yeah, that's
Sorry?
right. Yeah, I think you missed out on this term.
Yes, ma'am. Yes, ma'am.
Yeah.
Okay, ma'am. Thank you, ma'am.
Yeah, nothing else, right, or no? Yeah. Okay, Danya, you can ask
Yes,
your
ma'am.
question.
Now I'm
Yeah.
done.
Yeah.
Activity question 10.6, question 3. Sorry, ma'am, question 2.
Okay.
I just want to know for finding, yes, ma'am, like, could you just solve it? I'm unable to do.
Okay. Yeah, so if x and y are independent random variables and variance of 3x plus 3 is 27 and variance of 5y plus 10 is 150, we have to find standard deviation of x plus y. Since we're given variance, we'll first find variance of x plus y. So x and y are independent, so variance of x plus y is
So
just
the variance of a constant, will it be 0, ma'am?
yeah, variance of a constant is 0. So from the first thing, we can say that variance of 3x plus 3 is just variance of 3x is
The
27.
variance of x is 3.
Yeah, 9. We're taking this 3 outside, it'll be 9 into variance of x. Yeah. So variance of x will be 3. And similarly here, we can say variance of 5y plus 10 is just variance of 5y equal to 150. Taking 5
After this,
outside.
I'll solve, ma'am.
Sorry?
So I think after this, I can solve. Then you have to find
Yeah.
variance of x plus y and then do root.
Yeah, exactly.
So, ma'am, and in activity question 10.2, question 1, 2, these are theory questions, ma'am, and question 8.
Yeah. Um, I'm not sure how to explain this question to you. Did you go through all the videos?
Yes, ma'am.
Yeah, so the first one, the answer is if it's infinite, right?
So it was in the lecture number 2, explain it like this.
It's just because I'm not sure how to explain it actually. I would just say that anything.
Okay, ma'am.
Yeah, if
You can
the
explain the 8th question, ma'am. You said that.
8th one, okay. Like this one, I would just for the first one, I'd just say it's because if you're doing something infinite number of times, then it will automatically just converge to the probability. Like yeah, I'm not sure how to explain it right now. So yeah, I'll just go to the 8th question now. So if the probability of x is equal to 0 is 0.2 in Bernoulli random variable, then expectation of the random variable is yeah. So we know that yeah. So in a Bernoulli distribution, we can only have 0 and 1, right? So what is the probability of x equal to 1? Daniel?
0.8.
Yeah, it'll just be 1 minus 0.2 or 0.8. So we can just find the expected value of x here. It'll be 0 into 0.2 plus 1.
Ma'am, this one, how do we know that p of x is equal to 1? Like, how do we know whether the value of x can be either 0 or not?
Because we're told that it's a Bernoulli distribution. In this distribution, you can only have 0 and 1. Just go through these lectures again. We can only have 0 and 1 in this distribution. So now it's just using the formula 0 into 0.2
Yes,
plus
definitely.
1. Yeah. It's that in this video in 10.2. Yeah. Anything else, Tanya?
Actually, this question was already asked, but
Sorry. You muted yourself.
I'm just taking the.
Yeah.
So from 10.3, question 3.
Question?
3, ma'am.
Yeah, Danya, I already
Yes, and I just want to know how did we take x is equal to 1, ma'am? Because there are 5 junior developers. So we can have cases as 0, 1, 2, 3, 4, 5. That's what
yeah, you can do that. I just took it as like getting I divided the five people into x1, x2, x3, x4, and x5. Now each of these xi's we made it a Bernoulli distribution, which is 0 if it's not a woman, and 1 if it is a woman. So each of these x1, x2, and until x5, it will follow this distribution, right?
Yes, ma'am.
Yeah. Just to find the number of women, we can just so let's say if x2 and x4 were women. So in that case, x1 would be 0, x2 would be 1, x3 0, 4 1, and 5 0. So to find the number of women, we can just add all these and we'll get 2. So that is the number of women. So that's why I put it as this. So now you can just add up the
Is that the number of men or is it the
No.
number of women? 2.
women.
Okay, I used 1 as woman. Okay.
Yeah. So what we have to find is
Success is woman and failure is not.
Yeah. Yeah, exactly. So this is what we have to find. So instead we can just find the summation of one thing. And we already know how to find the expectation of a Bernoulli distribution. So for one woman,
yes,
yeah, it would be 12 by 20. So yeah, this would be the Now you can just solve.
Can I just solve it once? I think I
I'll
missed out on the Bernoulli part. That's why I'm having that.
Yeah, so since this is a Bernoulli distribution, the success probability of a success is 12 by 20 because there are 12 women and 8 men. So the not a woman would be probability 8 by 20. So expected value of xi is 0 into 8 by 20 plus 1 into 12 by 20, which is 12 by 20. Now the
Yes, ma'am. Got it.
summation of expected value of xi will be, we'll have to sum it 5 times because we have 5 xi's. So it'll just be 5 into 12 by 20, which is 3.
Yes, ma'am. That's it.
Yeah. Yeah, Hari, you can ask your question.
Ma'am, I have a doubt in terms of how you did solve with this question number 2, where you said x1, x2, x3 is almost equal to x in question number 2. No, maybe question number 1, part 2, I think.
This one?
Yeah, yes, ma'am. Yeah,
No,
where
I didn't say it's almost equal. I said these follow the same distribution. Because
yeah, go
yeah.
ahead, madam.
Yeah, I said these follow the same distribution because each xi is just the number on the ith ball. So x1 will be the number on the first ball, 2 on the second, 3 on the third. So it's independent and it's the same distribution.
So xi will be 1, x2 will be 2, and x3 will be 3, right? Like if you leave aside the expected value, the values that are provided, x1 is equal to 1, x2 is equal to 2, x3 is equal to 3, but the general expected value is 3.
No, that's not what we're saying. We're saying x1 will be so if we have so in the first one we have 4 balls, and if we're taking one, then it could be 1, 2, 3, or 4.
Yes, madam.
So x1 could be either 1 or 2 or 3 or 4. It's the number on the ball.
Yes, madam.
Yeah. So x2 will be the number on the second ball drawn, and 3
Which can also be either 1, 2, 3, or 4, but the general expected value which we calculated is 3. Like that is what we generally expect to be the value. Now, when we do sum expectation of sums equal to sum of expectations, given this x1 can be either 1, 2, 3, or 4, for which the expected value is 3, we multiply it by 3 times. Is that what happens? Is that the logic that is used?
Could you just repeat what you said about the given thing, the given parts?
When we do expectation of sums, where we are doing expectation of x1 plus x2 plus x3, we consider the fact that the expected value is 3 when we take a random number.
One, yeah.
So that is why we multiply it by 3.
Yeah.
Ma'am, I generally have
this 3 comes from the fact that we have x1, x2, and x3, and this 3 comes from the fact that expectation of xi is 3.
Yes, ma'am. I generally have a doubt in terms of how, in certain cases, given there will be a common distribution, you will go with choosing 12 times or 10 times, like n times the expected value. I'm struggling with a question in the graded assignment that has a similar sort of logic. So I wanted to know if I can figure out what the logic is. Like to define an event to have like the common distribution, like how to.
Yeah, so in this case, were you listening when we solved this question and this question?
Yeah. Yes, ma'am. Yes, madam. I was able to understand. But in certain cases, I find it difficult, like how the expected value for each, like it can be this expected value that we calculated when we take up a random variable.
I mean, in most cases, we'll be selecting a number of things, And so when we'll have to divide it into n different random variables, and each
Okay.
random variable will, since we've only learned Bernoulli distribution, it'll most likely be only a Bernoulli distribution. So it will.
There is a case which either takes a success or a failure.
Yeah.
Right?
Yeah. And in this case, we only had to count the number of women. So in that case, you can just take 0 and 1, because one will just be the presence and 0 will be the absence. But in this case, you can't take 0 and 1 because you're not finding the number of defectives. You're finding the profit itself. So you'll take X as the profit or the loss.
Okay.
You'll take it as 2000 minus 10,000.
Okay, when we are asked about the expected number of women, okay, when we are given a case where a certain number of in a group, certain amount of people are from a certain gender, such situations where we are asked to find what is the expected number of women, then
When
we
you have
can.
to find the expected number, this is the keyword. So if it's a number, if it's just a count, then you can just take 0 and 1. But if it's something else, like if it's the profit,
Okay.
then you'll have to take the profit itself as the random
Okay.
variable. Yeah.
Okay. Okay.
Now the
Thank you.
profit, the
Madam, go ahead.
probability, the probability will be very easy to find. Like this thing from this sentence, you can just find the probability of women and men. That will be that's the easier part.
Yes, madam, I understand.
Yeah.
Thank you. Thank you, madam.
Yeah, so I don't see anyone else with raised hand. So it's almost 8, so we'll close the session now. You can leave. Thank you for joining.
Politics.
Ma'am.
Not over.
Ma'am.
For those who